Hello everyone, how is it going? I am Dev Singh Raghunandan and you are watching Codev. In this video, we are going to discuss about the linear search that is considered as one of the most easiest algorithms in the data structure. And in this video, we will discuss a lot of things about the linear search, like the complexities associated with the linear search, like time complexity and space complexity. And we will also discuss its advantages, its disadvantages, and the one of the most interesting things, its real life use cases, like that is it is considered as one of the most easiest searching algorithms. Then we will also discuss about the real life use cases, that in which fields it is being used by us in our daily life. And we will dry run on an array, and in the by the end of this video, I will write the code on VS Code for better explanation and understanding. So without further delay, let's get started. uh, mhm, let's get so linear search. Yeah, we can look at the document first. Like linear search, in linear search, we have to match the values, like match the target value with the element at each index of the array. And if it matches, then we have to just return the true. And if it does not matches, then simply we can return the false. So like if we start traversing in the array from the very first index, like the zeroth index till the end of the array, like it will be n minus 1th index of the array. Like we will first match with the 0th index. 4 is not equal to 7, then move on. Then 7 is equal to 7. In this case, it matches at the index number 1. So what we can do is that return true, or based on your use case, you can return whatever you want. So in that case, it will return 1, return true, as it matches to the 7 at its first index. Like if we make it something, let's say I'm making, sorry, I have to insert a text like here. Like if I'm making it, let's say 9, then what it will do, first it will match with the 4, 7 does not matches. Then the next index, 7 do not match with the 9. Then next index, 7 do not matches with the 9. 7 with minus 1, again it is not matching. Like then if it not matching, then we will increment the index by 1 for further checking. Like 7 matches with the 5, no. So move on. 7 matches with the 8, then move on. 7 matches with the 10, no, move on. Now, after the 10, what will happen is that we are out of the bound of the index. Like the array size is 1, 2, 3, 4, 5, 6, 7. If I'm not, it is 7. So the last index will be 6. Now, since we have matched with the 10, now what it will do, the pointer will be at the 7th index, which is not present in the array. So we have, what it indicates, that we have reached the end of the array and the element 7 is not present. So in that case, we can return false, and you can also return 0 or something. It depends on your use cases, that in which case you are using the linear search, and you can return it accordingly. So that was all about the dry run. And talking about the time complexity, it will be better that if we will discuss it after writing the code on VS Code. So let's get back to our VS Code editor. I'm writing the code in Java language. So the main function, we can write int array new int. Let's say I'm creating the array of size 7, something like that. And I can also initialize it here. Not need to, like, let's say if the first element is -1, second element is 9, then 5, then 4, then 6, then 7, thala for a reason, then 5. I think these are enough. We can also get the length of the array using array.length method. Array.ng array.length. Now we can also fix a target element. Target is equal to, let's say, 7. So what we have to do is to search for the 7 in our array. So we can create a function for that. Boolean result is equal to, we can name the function like linear search. No, not that. Linear linear search. Then we can pass the array and the length and also the target element. And the result we can print using a shout. mm, Target ELE. Target element is present. We can print in front of it like true or false some result. That's great. Now we can write our function linear search. Since it is accepting the boolean, so we have to make it a boolean type. So public static boolean linear search, and the parameters are array int n and target value. So what we can do is start searching in a linear fashion. For searching, we will use for loop. For int I is equal to 0. I'm initializing with I with 0, and for I is less than n, or you can also write I is less than equal to n minus 1. Since we have to traverse till the n minus last index will be n minus 1, and increment the index by 1 uh, you every time the condition is changed. And now we can check for the target value if array, let me store it in a variable for better understanding. Int current element is equal to array of I. Now we can check it if current element is equal to target. If it matches, then it will return true, and it will return false if we have traversed the whole array and still we have not found that particular target element. So in that case, it is going to return false. That's great. So this is the very simple code of the linear search, and let me check it if there is an error or not. Before running or submitting a code, make sure that there is no error like a typo. You cannot check the logical error before that. Like target element is present, true. As we can also see that the target element was 7 and it is present at this index. Now, what if we change the target element to 99, which is not present in the array? Let's see what it is going to give the output. And in this case, it is giving false. That means our code is correct. So let's discuss about the complexity and further advantages, disadvantages, and all that. Let's go into the document mode. So, since we are in the worst case, you can see that we are we are searching for the target element from the very first index, from 0th index till the n minus 1. In the worst case, you have to search for all the elements. So, in that case, the time complexity is going to be order of n. Since while calculating the time complexity, we always look for the upper bound. So, we are taking the worst case here. And space complexity, since we are not using any extra space, so space complexity will be order of 1, or you can say constant. And talking about the advantages of the linear search, let me see if it, oh, that's great. Advantages of linear search. Linear search is more useful in scenarios where the data size or the data set is very small, like the range of elements are not very large, and if the data is given to you in an unsorted fashion, so you cannot do anything like binary search. You cannot apply that, so you have to go for the linear search. So linear search, in that case, it is very useful. And also in the linked list, it is very useful. Like linear search is used for the searching for a particular node, and even if you have to delete a particular node, you have to search for that in a linear fashion. And also in the graph, uh, like we do BFS and BFS using queues and DFS, which is based on the stack. Even though we are using BFS and DFS in the graph, but the traversal is in the linear fashion. So that is the another use case of the linear search in the graphs. And talking about the applications of the linear search, let's say if you have to search for a particular contact in your phone, then what we you will do is that you will scroll down till the end, whether you until you find that particular contact. And if that contact is not present in your contact list, then it is 100% sure that if you have searched for the whole contact list, then you are till the end of the in till the end of that list. So that is the worst case. Like you have to check for the whole context till the end. That is the real life use case of the linear search. Like this can also be used for searching up. Let's say if you are searching for a particular file in your system, then you will start from the starting of that folder, and then you will search till the end of that folder to check whether that particular file is present or not. Like there is no fixed method for that. And disadvantages that linear search becomes inefficient in case when we have very large data sets. If we have very large amount of data, then if we are doing it in an let's say in the worst case, the order of n will be very high. So that is the disadvantage, or you can say that the inefficiency of the linear search. And another disadvantage is that if we have the data set in a sorted order, then there is no need to apply linear search there. We can use binary search instead, which will give us the result in log n time. There is no need to go for the order of n that is bigger than the log n. So this is the disadvantage, that if you have the data in a sorted fashion, then go with the binary search instead of the linear search. So this was all for today's video uh, about the linear search. I hope that you have enjoyed it and learned something valuable from this video. And if you think that you have got some values in your coding or something new, then make sure that you are liking the video, and if you will subscribe it, then that is great of you. That that is all for today's video. I'm ending it. Thanks for watching. Where is it?